Alright, this is lesson 58 for 7th grade, and today we're talking about symmetry. And this won't take too long, because this is just an introduction, but it is a geometrical process, so we're talking geometry today. And we will be talking about two-dimensional shapes, so things like circles, squares, things that you can find the area of but wouldn't have a volume because they're not three-dimensional. So we're doing two-dimensional shapes, anything that you can draw flat on a piece of paper. Those are the main shapes that we're talking about today. Okay, so for instance, a triangle. It says here, two-dimensional figure has reflective symmetry or line symmetry if it can be divided in half so that the halves are mirror images of each other. So the example they give, line R divides this triangle into two mirror images. So the triangle is symmetrical, and line R is a line of symmetry. So this would be the line of symmetry. And when they say reflective, they say a mirror image, because we can think of this line here, where if that was a folding line, if we were to fold this across that line, these two halves should match up perfectly. So mirror images. Alright? And it is possible to have more than one line of symmetry. For instance, the regular triangle has three lines of symmetry, because a regular triangle, all the sides are the same and all the angles are the same. So we can split it in half here, here, and here, and all of those would be lines of symmetry. So the regular triangle has three lines of symmetry. Okay, now this one says, draw a regular quadrilateral and show all lines of symmetry. Okay, so quadrilateral, that's a shape that has four sides, and we want it to be regular, so all the sides have to be the same. So that would be like a square. We can imagine that it'll be the same. I'm not the best at drawing a perfect square, but lines of symmetry, we could have one that goes this way. Okay, they could split it in half like that. That's one line. We could split it in half the other way, like this. Okay, so the first way, if we folded it like that. Second way, if we were to fold it like that, those would be two lines of symmetry. We could also do it with the corners. So from here to here. So if we were to fold it across that line, the corners would match up evenly, and this way too. Alright, so we have four lines of symmetry there. So there are four of them. Alright? Okay. Okay. Then they give this neat example. It says the y-axis is a line of symmetry for the figure below. Notice that the corresponding points on the two sides of the figure are the same distance from the line of symmetry. So for instance, if we folded it across the y-axis, that's right here, we would get matching halves. And it says to notice that, for instance, this point and this point correspond to each other. They are the same distance away and at the same height, or at the same x or y value, they're up to. But they're the same distance away from your y-axis. It's 1, 2 away, 1, 2, and this one's also 1, 2 away, 1, 2. Okay? This one is 3 away, and this one is 3 away. So those two are the same distance apart. Okay? So that's one thing that we can do when we're plotting points and making symmetry on our coordinate plane. We'll use that if we ever need to reflect something. We could also reflect across the x-axis, and we've also got other lines of symmetry we could use, but we won't get into that until a little bit later, and especially more so as we get older. Okay, so if this figure were folded along the y-axis, Each point of the figure on one side of the y-axis would be folded against its corresponding point on the other side. So if we were to fold, like I was talking about, this point and this point would match up, and this point and this point would match up. Alright. Now we have this thing also called rotational symmetry, and that is a figure has rotational symmetry if it reappears in its original position more than once in a full term. So they give the example, the uppercase letter S and I, so these letters right here. If we were to rotate them, let's say, in a 360-degree manner, at some point before we got back to its original position, these letters would match up with, well, they would look the same as they do right now, but rotated at a different degree. For instance, if we rotated 180 degrees, or if we rotate our book upside down, okay, so let's take this paragraph and turn it upside down. Alright? We still get an S, an I, and an S. Alright? So this would be a 180-degree turn. So imagine your S, one rotation. That would be a 90-degree rotation. So that's taking it and going that way. Now if we take this and go one more, we still get an S. Or if we look at our I, it starts right here, rotate it once, goes like that, rotate it again, and we still get that. And that's before we've rotated a full 360 degrees. So we would call these, they have rotational symmetry, these letters do, because obviously before we get to its original position, again, we get the same letters, okay? So pretty cool. That's a mirror image right there, at least for these. Alright? Alright, last one here. So let's decide which of these does not have rotational symmetry. So if we rotate these at some point, will they not be in the same position before we get back to the original position? So here's the original figure, here's one turn, and then if we rotate it again, we get this, and that's before we do it 180 degrees. The triangle, if we rotate that once, it'll still be the same. So rotate that once, so bring this side down, we still get the triangle again. A square, rotate that, doesn't matter, we're going to get the square again. Rotate it once, we get a square. However, with D, so D should be the one that does not have rotational symmetry. Let's take a look at that. Let's rotate it, okay, original position. And then if we rotate it once, it will look like this. Rotate it again, it will look like this. Rotate it again, it'll look like this. And then rotate it again, we get the same shape. But that would be a full 360-degree turn. So D is the one that does not have rotational symmetry because it doesn't look the same as it does there until we get it back to its original spot. Alright, so we'll talk more about this tomorrow, and we'll have a little fun with it because it's a pretty fun topic. Alright.